Let's unravel the cosmic puzzle together. NASA's Voyager 1 spacecraft, the farthest human-made object in space, sitting an incredible 15 billion miles from Earth, has done the impossible once again. After days of silence, Voyager 1 has re-established contact with Earth, using a radio transmitter that hadn't been touched since 1981. That's over 4 decades ago. Although this connection is only temporary, it's a critical lifeline for the mission team to diagnose what's causing the issue. Currently, Voyager 1 is cruising through interstellar space at an astonishing 38,000 miles per hour, sending back faint signals from the edge of the solar system. However, 2024 has been a tough year for the spacecraft. It has faced a series of technical challenges, and this latest transmitter problem has raised concerns about how much longer Voyager 1 can continue its historic mission. This latest issue began during a routine heating command to the spacecraft. Voyager 1 relies on 3 radioisotope thermoelectric generators, or ART-Gs, to stay powered. These generators convert heat from the natural decay of plutonium-238 into electricity, a system that's been running like clockwork for nearly 50 years. But as we push deeper into the unknown, even this marvel of engineering is beginning to show its age. Stay tuned as we explore more about this incredible mission and the challenges it faces on its journey through the final frontier. As plutonium-238 slowly decays, the power output of Voyager 1's ART-Gs, radioisotope thermoelectric generators, decreases over time. On average, these generators lose about 4 watts of power per year, meaning engineers must make increasingly careful decisions about how to allocate the spacecraft's remaining energy. But that's not the only challenge. As Voyager 1 journeys through the uncharted territory of interstellar space, it faces a constant barrage of high-energy cosmic rays, radiation strong enough to take a toll on its electronics. This radiation can wreak havoc on the spacecraft's systems. High-energy particles can create microscopic flaws in semiconductors, weaken transistors, and gradually degrade the performance of electrical circuits. Over time, these small damages accumulate, causing systems to become less efficient or fail altogether. To combat these effects, NASA's engineers have developed ingenious solutions. One such strategy involves sending commands to activate onboard heaters. These heaters target specific parts of Voyager 1 that have been damaged by radiation. By warming these components, the spacecraft can recover some of its functionality. For example, heating semiconductors can help realign atoms that were disrupted by cosmic rays, effectively fixing tiny flaws and restoring the material's electrical properties. This process, called annealing, allows critical electronics to operate more reliably, even in the harsh environment of deep space. But radiation isn't the only danger Voyager 1 also has to contend with: freezing temperatures in the vacuum of space. Extreme cold increases electrical resistance in circuits, making it harder for electricity to flow efficiently. By warming key components, the heaters reduce resistance and improve system performance, giving this resilient spacecraft a better chance to keep exploring the cosmos. Even after nearly 5 decades, Voyager 1 continues to push the boundaries of what's possible, thanks to the brilliant minds at NASA who find new ways to outsmart the challenges of deep space. By strategically using heaters, engineers can stabilize Voyager 1, easing stress on the spacecraft and extending its incredible mission even after decades of enduring the harsh environment of space. On October 16, a routine command was sent to activate a heater on board Voyager 1. But then, something unexpected happened. Before we dive into what unfolded, let's pause for a moment. Imagine this. What if you could turn your ideas and creativity into stunning videos using nothing more than a simple text prompt? No steep learning curves. No expensive production tools. Enter InVid AI, a game-changing platform that puts video creation at your fingertips. Want to make a video about the fascinating mysteries of Pluto? Simply focus on your vision and let InVid AI handle the rest. For example, did you know Pluto is roughly 3.7 billion miles from the Sun? With InVid AI, You could easily create an engaging video about that and so much more. The best part? You're the director. Need to tweak something? Use simple text commands like translate to French. Want to narrate in your own voice? You can even clone it for a personal touch. You can try Envid AI for free, but if you're ready to unlock its full generative capabilities, the generative plan at just $96 per year is the way to go. Back to Voyager 1. What exactly went wrong? Stay tuned to find out. This month, the generative plan gives you 15 minutes of AI-generated video, saving you hundreds on editing and production costs. Already an Envid AI user? Just add generative seconds through the add-on section. Use the link and code in the description to transform your ideas into stunning videos today. Now, let's dive back into space. Commands to activate Voyager 1's heaters are sent from NASA's Jet Propulsion Laboratory, JPL in California, using the Deep Space Network, DESN. The DESN is a global system of massive radio antennas that allow communication with Voyager 1, its twin Voyager 2, and other spacecraft exploring the vast reaches of our solar system. Here's the mind-blowing part. When a command is sent to Voyager 1, it takes about 23 hours to reach the spacecraft, which is now over 15 billion miles away. After executing the instructions, Voyager 1 sends back engineering data to confirm its actions, adding another 23-hour delay. This means every interaction takes nearly 2 days, making each step a slow but methodical process. On October 16, the NASA engineers sent what should have been a simple command: turn on one of Voyager 1's heaters. But something unexpected happened. Even though the spacecraft had enough power to activate the heater, the command triggered Voyager 1's fault protection system. This system is designed to conserve power during unexpected events by shutting down non-essential systems if they start consuming more energy than anticipated. By October 18, Mission Control noticed unusual behavior in Voyager 1's systems. What caused this glitch? And what does it mean for the spacecraft's future? Stay tuned as we uncover more about this extraordinary mission. The issue started when Voyager 1's fault protection system unexpectedly altered the rate at which data was being transmitted. Then, on October 19th, the communication with the spacecraft seemed to stop altogether. The team believes the fault protection system activated 2 more times, ultimately shutting down Voyager 1's primary X-band transmitter, its main line of communication with Earth. Voyager 1 communicates with us using 2 key frequencies, the S-band and the X-band. Think of them as different radio channels, each serving a unique purpose. The S-band operates at a lower frequency, around 2 Gs. This was Voyager's go-to frequency in the early days of its mission. It's like an old, reliable radio, perfect for basic communication. The S-band is great at covering long distances, but it has limited capacity to carry data, much like a slow, outdated internet connection. The X-band, on the other hand, is a more advanced channel operating at around 8 Gz. As Voyager 1 traveled farther from Earth, the X-band became its primary frequency. Why? Because it can carry more data and send signals faster. It's the difference between a basic radio signal and a high-speed internet line, allowing us to receive cleaner, more detailed information from the spacecraft. With the primary X-band transmitter now offline, the team faces a major challenge. How can we re-establish communication with Voyager 1? And what does this mean for the future of the mission? Stay tuned as we unravel the mystery of this remarkable spacecraft's resilience. The X-band transmitter on Voyager 1, operating in the reliable 8 to 12 Gs range, has been the spacecraft's primary communication channel with Earth for decades. But with the X-band transmitter now offline, Voyager 1 automatically switched to its backup S-band transmitter, a weaker, less efficient system that hasn't been used since 1981. This created a significant challenge. The SU-band signal is much weaker, and given Voyager's incredible distance from Earth, the team wasn't sure if they'd even be able to detect it. Yet, against all odds, Voyager 1 surprised us once again. Using the Deep Space Network, a global system of advanced radio antennas, an ASA successfully located and locked onto Voyager's faint S-band signal, re-establishing a critical connection to the spacecraft. While this connection is only temporary, it's a major win for the mission team. Now, engineers are proceeding with caution. They're holding off on reactivating the X-band transmitter until they fully understand what caused Voyager 1's fault protection system to trigger. Diagnosing the issue is no small task. With Voyager's extreme distance, every signal exchange takes nearly 2 days for a round trip, requiring patience and precision. The team must also ensure there's no risk in attempting to reactivate the X-band transmitter. While the spacecraft has overcome countless challenges, this one reminds us just how delicate yet resilient Voyager 1 is, as it continues its groundbreaking journey through interstellar space. Restoring Voyager 1's X-band transmitter could be a game-changer. If engineers can bring it back online, it might reveal crucial details about the malfunction, giving the team valuable insights into the spacecraft's condition and helping them plan its future operations. The backup S-band signal, while a lifeline, isn't a long-term solution. It's too weak to retrieve telemetry or science data, but does allow engineers to send commands and confirm that Voyager 1 is still pointed at Earth. This transmitter switch is just the latest in a series of brilliant problem-solving feats by the Voyager team to keep the mission alive. Earlier this year, engineers reactivated thrusters that hadn't been used in decades to adjust the spacecraft's orientation and ensure its antenna remained aligned with Earth. And let's not forget the ingenious fix to a computer glitch that had disrupted science data for months. The team resolved the issue by breaking the corrupted code into smaller pieces and storing them in different parts of Voyager 1's flight data subsystem, a creative workaround that saved the mission from a major setback. These innovative solutions are a testament to the team's unwavering dedication to preserving this historic mission, even after nearly 50 years in space. As Voyager 1 journeys farther into the unknown, every decision, every fix, and every bit of power saved is a victory not just for the spacecraft, but for humanity's quest to explore the cosmos. Voyager 1 isn't the only one facing these challenges. Its twin, Voyager 2, the second farthest human-made object from Earth, is also being carefully managed as its energy supply dwindles. Recently, NASA engineers made the difficult decision to deactivate Voyager 2's Plasma Science Instrument, PLS, to conserve power. This is just the latest in a series of sacrifices necessary to keep the spacecraft operational. Launched on August 20, 1977, just 2 weeks before Voyager 1, Voyager 2 was equipped with 10 scientific instruments to explore the outer planets and beyond. It holds a special place in history as the only spacecraft to visit all 4 gas giants: Jupiter, Saturn, Uranus, and Neptune. But like its twin, Voyager 2's power source, a trio of radioisotope thermoelectric generators, has been steadily losing power over the decades. This gradual decline has forced the mission team to make tough decisions about which instruments to keep running. Of the 10 instruments on board, 6 have already been turned off over the years. And now, in 2024, the 7th instrument, the PLS, has joined the list. The PLS wasn't just another tool. It was one of the most critical scientific instruments on board. Designed to measure the velocity, density, and temperature of plasma, it played a key role in Voyager 2's historic journey. In 2018, the PLS confirmed that Voyager 2 had exited the heliosphere, a massive bubble of charged particles created by the solar wind, and entered interstellar space. Even with this loss, Voyager 2 continues its remarkable journey, sending back invaluable data from the edge of the solar system. Each instrument that's deactivated is a bittersweet reminder of the spacecraft's aging systems, but also of the extraordinary legacy it has built over nearly 5 decades in space. At the heart of our solar system, charged particles flow outward from the sun, creating a protective shield that guards us against harmful cosmic radiation. Voyager 2's plasma science instrument played a pivotal role in studying the solar wind, measuring its properties and pinpointing the exact moment when the solar wind weakens, marking the spacecraft's approach to the edge of interstellar space. This milestone was a huge achievement because Voyager 2 became the first spacecraft to directly measure plasma density beyond the heliosphere. Voyager 1, which crossed into interstellar space in 2012, wasn't able to make these direct measurements. Why? Its plasma science instrument stopped functioning back in 1980 and was permanently deactivated in 2007. As a result, scientists had to rely on indirect data from Voyager 1's plasma wave subsystem to infer its crossing of the heliopause, the boundary where the solar wind meets the interstellar medium. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.